Let us check some useful operators. There are a few built-in functions and operators in Python. They don't fit into any categories. For example, range. The range function helps you to quickly generate a list of integers. The syntax is a range, open close parentheses, you have a starting point and you have a terminal point. But please note that since it's a generator function, to actually get a list out of it, we need to cast it to a list. So if you run the following cell, you have a list and you have your generator function range. The starting point is 0 and the terminal point is 11. What does it do? It basically generates a list of numbers from 0 to 11, but 11 is not included in the list. So just please pay attention, the last number is 10. However, if you want to see 11, you have to add 12 as a terminal point. So now if you look at the list of this generator function range, we see that it ranges from 0 to 11, and 11 is included here. Now we can add the step size. If you don't add any step size here, by default it is 1. When we add the third parameter, the step size, in this case, for example, 2, and we look at the list that is generated by range function, we see we have 0, jump into 2, jump into 4, jump into 6, jump into 8, jump into 10. Let's take a look at another example. This generator function range starts at 0 and it stops at 100. 101 is not included and step size is 10. Well, let's take a look at the result. The output is going to be a list starting at 0, jump into 10, jump into 20, 30, and you can basically follow the pattern here. Let's take a look at how we can enumerate. Enumerate is a very useful function to use with for loops. Let's take a look at the following situation. We're going to set a variable index underscore count to be 0, and then we're going to use a for loop. Letter in the string A, B, C, D, E. What it's going to do for this letter in this string, it's going to print out the index and the letter for us. So it basically shows how to iterate over a string. In this case, our string is A, B, C, D, E, and while keeping track of the index of each character. So this is the output of this code. At index 0, you have letter A. At index 1, you have letter B, and so on. Let's break it down into smaller pieces. This line of code basically initializes a variable index count to be 0. This variable will be used to keep track of the current index. Now, for your for loop, this line starts a for loop that iterates over each character in your string. The loop executes once for each character in this string. You also have a print statement. This line basically prints a formatted string for you, including the current index and also the letter. And finally, what are we going to do? We're going to use the operator plus equal to, and we're going to add 1 here. As you remember from the beginning of the class, we introduced this operator. It basically increments the variable by 1 after each iteration of the loop. This guarantees that the index will correctly reflect the position of the letter in the next iteration. Let's rewrite this line of code. I'm going to just use a for loop. This basically loops through each letter in the string and also its position or its index. So what's happening here? For I, comma letter, I gets the index and then the letter gets the character. For example, in the first round, I is 0 and the character is A. In the next round, I is 1 and the character is B, and it continues this process. We have some good functions for a random number. You can either use numpy or random module like random, randed, randrange, choice, shuffle, seed, or using the numpy, np.shuffle, np.rand, np.randed, np.seed, and some secret modules like choice. Let's take a look at a few of them. Random. Python basically comes with a built-in random library. There are a lot of functions included in the random library. For example, suppose you have a list including 10, 20, 30, 40, and 100, and your goal is to shuffle this list. So first, from random, import shuffle, and then basically shuffle your list. If we look at the new result, we get my list, which includes 40, 100, 10, 30, and 20. The same numbers, but in different order. If you rerun this line of code, you get a different result. Arange. Arange is a numpy function used to generate arrays of evenly spaced values within a specific range. It is similar to Python built-in range function, but returns a numpy array instead of a list. So here's the syntax: np.arange, starting point, stopping point, and the data type. For example, let's take a look at np.arange. The starting value is 0 and the stopping value is 10. It generates a numpy array that contains a sequence of evenly spaced numbers starting from 0 and ending just before 10. But again, please pay attention. The difference between range and arange. For arange, you get an array back. Another example for you. Now here, I'm just basically adding the step size. It starts at 0, then it jumps into 2 because of the step size 2, jumps into 4, 6, and so on. Zeros and ones. This is especially useful when you're taking linear algebra class. You can basically generate vectors or matrices of zeros and ones. np.zeros n takes a parameter like n to create a one-dimensional array of size n. It only has zeros. For example, np.zeros, if you pass in 3, it creates a one-dimensional array of shape 3. It means that you have a vector with just 3 components, which are just zeros. You can also generate a 2D numpy array using the following syntax: np.zeros. Please pay attention to these two sets of parentheses here, A and B. For example, np.zeros, if you pass in 5 and 5, you expect to get a 5 by 5 matrix with only zeros in them. The first row of the matrix, the second row of the matrix, third, fourth, and fifth, the first column, second column, third column, fourth column, and the fifth column. The same process with ones. np.ones, if you pass in 3, you expect to get a vector or an array with only 3 members, 3 elements, which are all ones. You can create 3 by 3 matrix, for example, which includes only ones. The first row, second row, third row, first column, second column, and the third column. What is linspace? So linspace is a numpy function used to create an array of evenly spaced numbers over a specified range. np.linspace, you can pass in 3 parameters. The first parameter is the starting value. It is inclusive. It means that it is going to be included. And the second parameter is the stopping point. And finally, you have the third parameter, which is the number of evenly spaced values to be generated. For example, if you look at np.linspace 0, 1, and 21, we expect to get 21 numbers in between 0 and 1 inclusive. Take a look. The output is an array starting at 0 and stopping at 1. And you want to have 21 numbers. So they are evenly spaced. So from 0% to 5% to 10% to 15% to 20%, 25%, and so on. Let's take a look at another example. Here, we want to generate 100 numbers starting at 10, stopping at 1,000, and we want them to be evenly spaced. So as you can see, the starting value is 10, jump into 20, 30, 40, and the last number is 1,000, and all of them are evenly spaced. The distance between each number is 10